Hi everyone, I'm Felix and I'll be going over problem number 3 Pokemon on this worksheet. The problem states to identify the errors that occur when writing the code to the right. I've copied it down below and made it larger for convenience. Before that, let's revisit how casting works in Java. In this problem, we have a class Pokemon with two subclasses, Pikachu and Squirtle, that both extend Pokemon. Now what this means is that if we have a variable of type Pikachu or Squirtle, we're able to upcast it to type Pokemon, and vice versa. If we have a variable of type Pokemon, we're allowed to downcast it to type Pikachu or Squirtle. Now keep in mind that you are not allowed to cast in between subclasses. It wouldn't make sense to say that my Pikachu is a Squirtle after all. Casting also only concerns static compile time. This is in contrast to dynamic time method selection, which is how methods are selected to be run once the code is actually being run. For example, we could have a variable z of static type Pokemon, but the actual dynamic type is Pikachu. So when the code is actually being run, the dynamic type Pikachu is used in order to select the methods to be run. Now that was a big mouthful, but don't worry, this will make more sense as we go through the problem. I'll be doing two things at once, keeping track of the static and dynamic types of the variables we encounter. Just know that in reality, the Java compiler finishes all of its work before the codes actually run. Let's begin by looking at this first line here. We're creating a new Pikachu object and assigning it to a variable p of static type Pikachu. Let's note this down. P will have a static type of Pikachu and a dynamic type of Pikachu as well. This line will run with no issues. In this next line, we're assigning the value of P to A, where A is a new variable with static type Pokemon. So let's note it down. The static type of A is Pokemon, and the dynamic type will be Pikachu. Now this is perfectly fine. Well, why? Because Pikachu is a Pokemon. That's reflected in this model above here, as well as since Pikachu extends Pokemon. However, this next line leads to another issue. The issue is that, well, all Pikachu are Pokemon, but not all Pokemon are Pikachu. So this will actually lead to a static compile time error. Let's examine the next line. In the compiler's eyes, it will use the static type of A, which is Pokemon, and try to match a method with this signature and name. So since A has a static type Pokemon, which we've noted here, and because of this line right here, the compiler will simply just go to the Pokemon class and look for a method that has this name and signature. It turns out there is one with this name and signature. However, when this code's actually run, the dynamic type will be used in order to select what method will be run. So when we actually go to run this code, since the dynamic type of A is Pikachu, from this line up here, the code will actually look over here and use the E in the Pikachu class because, well, the dynamic type is Pikachu. This means that this line here will print non-Pika nom. Let's continue. In this next line, we're assigning A to a new Squirtle object. This means that the dynamic type of A is going to be updated from Pikachu to Squirtle. This line runs with no issues. Looking at this next line, we can follow the same reasoning as this line above. Again, the compiler is going to use the static type of A, which is Pokemon, in order to see if there's a method with this name and signature. The compiler looks in the class Pokemon and finds something that's pretty close, but alas, the method signature doesn't match. So this will actually lead to a static compile time error. Now you may be thinking, well, we know that the type of this dynamic type is Squirtle, so I mean, we know that the Squirtle has a method that has a signature and name. So let's remedy it using a cast. So in this line, we've downcasted the variable A from type Pokemon to type Squirtle. Remember that this is perfectly fine because Pokemon is a parent of the subclass Squirtle. So now when the compiler goes to this line, it'll look in Squirtle class and find that, okay, there's a method with this name and this signature. So the compiler will pass over this line with no issue. Now when this code, again, since the dynamic type is Squirtle, when this code's actually run, it will also use this method right here. So when this line is reached in the code, it will print water gun. Alright, so in this line we're introducing a new variable z with static type Pokemon. and we're creating a new Pikachu object. So dynamic type is going to be Pikachu as well. This line runs with no issues, the same reasoning as previous lines. Now, we're looking at this line in the eyes of the compiler. Since you're allowed to downcast a variable of type Pokemon to type Squirtle, the compiler will look at this and it will just pass. It will say that this is fine. Because, well, yeah, sure, we're just assigning a variable of type Squirtle to type a new variable of type Squirtle. However, when we go to actually run the code, Z's dynamic type is the type Pikachu. And remember what I said above about not being able to cast in between subclasses? So this will actually lead to a dynamic runtime error, despite the compiler not catching it early on. So this is really important because, well, the static types and dynamic types are different, and they both play their own roles. Finally, looking at this last line, we see that we take the Pikachu variable of static type Pikachu, and we upcast it to type Pokemon, which is allowed, again, because Pikachu is a subclass of Pokemon. So when the compiler looks at this, it will just simply look and try to find a method that matches the signature, where Z is a variable static type Pokemon. So it will just look in the Pokemon class, and it will find attack right here, and it has the right signature. So the compiler will give this line the OK, and it will be run. And this also runs with no issue. Once we actually run this code, it'll also lead to no issues because the types all match up. Since P under the hood is dynamic type Pikachu, and Z is dynamic type Pikachu as well. They're all Pokemon. Alright, so this concludes the walkthrough. If you have any questions, please ask your CSM tutor. Have a good day.